design and implementation, keep in mind as well that usability assessment is not to be done just once, right? But it can be done frequently to confirm that your system is good for the user, can really support the user's work. Because otherwise, users may not use your system. And that's even more painful, right? You develop the system, no one uses it. Okay, but I am back to the design, okay? We already talked about structural model, dynamic model, and so on. Related to the UML diagrams and many types of diagrams that we discussed, okay? I will go very fast. I think I will skip all this, okay? It's just some, how to say, design principles that you should have in terms of object-oriented design and technical design related to UML and so on, such as your class should have cohesion, the program should have low coupling when you really develop your code and your system, so on. But I will move to the implementation. Focus more on the implementation, assuming that everything is complete now. You have your system almost ready. Actually, keep in mind as well that when we use agile, okay, agile modeling with agile would mean just in time, because agile believes that everything would be changing, possibility of requirements changing, and many things are high in the current world. So make an initial architecture modeling is okay, but just if it is necessary. Don't do things long time ahead. Okay, but of course you may need to define core architecture that it will include this component and so on and so on. But it should be not too much detail, because and you put into the detail when it's necessary to implement that part for real. Because actually, if your system is very large, right, you do the whole initial architecture design, that is fine, but it could be a rough design, and then you design in the detail of each part when it is necessary, using iterative evolutionary modeling technique, or we call it just in time as well. Okay, this means the detailed design is done just in time, but the initial overview design could be done from the beginning. That is fine. Okay. Okay, once you have certain modules, components ready, in terms of implementation, of course, implementing a system involves, after the design, coding. It involves coding, testing. Installation means deploying it, right? Documentation, training, and support. But again, as I said, this can be done iterative and repeated manner. You can deliver one module or component at a time. Continuous delivery approach. Don't wait until you finish everything and deliver just one goal, right? Deliver small parts, let the user use it. Deliver another additional part and let the user use it. Okay. So all these coding, okay, testing. Okay, let's talk about testing. When we do the testing, there are different types of testing that you may need to involve, because testing ensures that your system, your code is accurate, is correct, and it does the thing that the users would want it, right? So there are 4 types that we can talk about the testing. First, it is static. Static means it's not really executed. Maybe you just read the code, okay? Dynamic, you run the code and see the result, whether it's correct or not. Automated, there's automatic testing tool nowadays, and in which that is very convenient as well. And manual means that we use people to perform the test. Okay? And in another dimension, we can define the types of testing into code inspection, okay, a technique that you examine the code, okay, by programmers, user, not the user, programmer, developer, okay, or techniques called walkthrough. You walk through the program to understand and review the code, okay, and there's checking, in which this is a technique to execute each part of the code manually, okay, and then the unit testing. You test each unit, each module in a standalone unit, not yet integrated, but just make sure that this unit, this function, this method works correctly. Then we could have integration testing. You combine several units, right? Modules or functions to work together and it still works. So that is integration test. System testing, the whole system after we have many things, all the components connecting, working together. That is the system testing. Sub testing is when you test each particular module and then call a module when it is not fully written. Okay. So actually testing is very important. And you need to be sure you perform the testing to confirm that it satisfies the requirement. Not only that it is bug-free, but to ensure that it does the thing that the requirements say it should do. Maybe your program is entirely bug-free, but it doesn't do what the user wants to do, right? That is also important too. And when we define test case, when you test the system, test the program, test the unit, test the module, test whatever, there are 3 types of uses that you may need to test. Typical use. In most of the ordinary case, most users will use it this way. Most users will enter this kind of data. Okay. Second, abnormal system use. Maybe there are some users who may want to try out or challenge the system as well. Okay, so there are cases of abnormal system use that you need to try as well. Pretend you are abnormal user. You want to challenge the system in some way, whether it is the system will crash, will not be working or not. Critical system. Okay, also when there are maybe critical peak load or some issues happen, how the system will be. Will it crash? And so on. Okay, so you need to be sure that several of the cases could be handled, could be taken care, could be done properly by your system. When we define a test case, this is one example that you could do as well. If it is a kind of unit test or module test, okay, you need to define the name of the module. What are you testing? Such as Google login screen. Okay, what is this module you are testing? What are the test steps? What are the test data? What are the expected results you assume? What is the actual result you obtain? Because expected and actual, if they are different, it means that the system may have some kind of error or do not work in the way that it should, right? And status of the test, whether it pass or fail, so on. So these are the way, the proper, the very, sorry. The way you record the test case and the result. So that if actually it depends. If you don't have systematic way to test, right? You just think that, okay, I try with this user ABC. And then I try with this user XYZ. And then I try this and that, right? Maybe it really the whether you can come up with complete cases of several possible cases or not. If we are just talking about login, okay, actually this is very easy example and easy module. Typical system use, there could be two things. There exists a user account, there exists user ID, and the password match, right? Another scenario is that the user ID doesn't exist, right? I type something that there's no such user. And another scenario is also user ID and password do not match. So these are typical scenarios that could happen for login. There may be some other ways. If you know about SQL injection and so on, there could be a way to really try to hack the system account through some techniques, okay? And if you know those abnormal cases, is try to detect this. And critical system use, maybe when there are kind of million users try to log in at the same time, what will happen? Or when the database, user database fails or something, what will happen? Okay. And this is about ATM change in service. So there are steps, right? Expected system response, pass or fail, and so on. Whether you make it correct, wrong, and so on. These are to define by many cases, several cases to cover possible scenarios. And I mentioned also that there are automated testing environments, okay, that make use of testing engine, okay, and test script that you can just run, generate several cases of the test automatically. And that is very good because manually running the test by human, I think it's time consuming, right? But if you can write a script to do the test, that is very efficient and fast. But you need to define different types of tests and the script. So we need to detect the errors. We want to make sure that if there are some kind of violation and so on, how the system handle, and whether there are certain flaws, errors, mistakes there or not. And this is an example of the test platform, the test engine, the automated one. And actually, many software companies, there are, right? There are designer, analysts, business analysts, system analysts. There are also testers, those who are dedicated to just do the test. Okay, I will. Those tests we discussed so far, they are to be done by development team anyway, right? They are part of the development team. But then there must be acceptance testing by the user. Once you as developer and the development team feel that everything is perfect, then you deliver your system for user acceptance, okay? So we want to have real actual users try to use the system, and whether he or she or the groups of users, sorry, would accept it or not. Two types of acceptance testing that you might have heard: alpha testing and beta testing. For alpha testing, it is the real complete system, but data is simulated one. Mock data, simulated data. For beta testing, it means real data in real user environment. When you design, there should be a stage of delivery and test, okay, launching of your system. Inside the alpha testing, we could talk about recovery testing, security testing, stress testing, and performance testing. This is to be sure that this is still in the simulated environment with simulated data, right, in the alpha testing. Meaning you need to force or simulate system failure and see how the system would recover. Okay, how well it could recover. Do we have data loss? Do we have any corrupt crash or anything? Security testing, okay, make sure, try penetration test, something like that. Okay, if someone wants to break into the system, will it be secure enough? Okay. Stress testing, okay, means beyond normal operation, such as I said, peak load. A lot of transactions coming in, a lot of login coming in, a lot of this and that. That is the stress testing. Performance testing, okay. Check the performance of the whole system for different functionality and transactions. Okay, so that's about the testing. Once everything seems very good, then you are going to deliver, deploy. Deploy means you install. You make it use in the real environment of the business, of the company. So there are many ways you can think about deploying. So I will talk about these 4 types of deployment and installation. Okay, the first one, direct installation, is easy. The easiest way. Now we need to think that it could be the case that you have existing system and you are the team develop a new system, okay, to replace the existing one. Either the existing one is a manual process, or either existing one is the legacy computerized system, but this is the existing system, how users in the organization perform the work at the moment, right? That is existing system. So direct installation means the current system means the existing system, okay? Before you have the current system, now we have to install new system and then shut it down. Shut the old system down and then start using the new system onward. After you complete the installation, that is the direct installation. Okay, that is easy, right? It's like you buy a new laptop, you transfer everything, then you throw away the old laptop and start using the new one, right? Okay. Another one, parallel installation. Parallel means, of course, you have a new system, you install it, make it ready, transfer the data, migrate the data, everything. Then you keep using 2 systems for some time. This is the time period that you use both systems at the same time. Once you feel confident that everything is fine, then you shut down the old system. Again, similar to you having new laptop, You transfer everything, but you're not sure whether the new laptop works well. Every time you have something, you work on both. Okay? And then once you are very sure of the new laptop, you shut down the old one completely. So pros and cons. Pros means if something is wrong with the new system, you still have the old system, right? To do the thing. If your laptop doesn't do well, you still can work on this and that using the old laptop. Compared to this, if something is wrong here, if something is wrong in your new system, what will happen? You just need to cry. You don't have the backup system, right? You may need to solve the problem on the new system anyway. But here, if something is wrong in the new system, you still use the old system somehow on those work and operation. That is the pro. Cons. You do things right. If suppose you are the doctor, this system means diagnostic system. You need to enter data about patient diagnostic here in the new system. Oh, this patient has a flu-like symptom. We need to give him the treatment. This. He has high fever. He has coughing. You key in, right? And we prescribe this medicine. You key in the new system, but you also need to key in the old system to make everything functioning and data up to date. So you work double, right? Because you are running two parallel systems. Okay. Single location installation is another way. It is like pilot. If you have many branches or you have many kind of departments or units, you may try out only on this pilot branch, pilot location, pilot department. Okay, so we can have this location doesn't need to be just physical location, right? It could be work, certain types of units still in the same hospital, it could be. But we work only for the section of skin department that try with this new system. Okay, but then the old and remaining departments, units within the hospital, we just still use the same technology and so on. So if we want to launch this D-Health, maybe we launch only with some small healthcare units first. That is also what we call single location or single pilot installation. Okay. So we could have installed new system while we have the old system, right? And then either this is to combine with direct installation. So in this pilot site, okay, you start using the new system in the pilot site by removing the old one, throw away the old one. And once you are very confident from the pilot site, you can continue with another site. Okay. Phase installation. That means you are doing things phase by phase, module by module, component by component, something like that. Okay. So the current system, the installation of the module 1, okay, you are still using the current system, the old system. Then once the module 1 is deployed and work well, you use the current system without module 1, but then the new module 1 is then in place. Okay, so for example, you launch the new D-Health system, only the part of making appointments, but other parts still not yet. So the old system, we don't use the appointment module, but we use the appointment module of the new system. Once the appointment module works well, we start launching another new module and integrate back into the old system, something like this. Okay, you need to really think about real business scenario. It's not like we throw away everything, right? But when we reintroduce a new system, how can we have the old system and new system operating in the business properly? Let's think about also banking. Okay, maybe banking is a very good example of legacy system because it's very big. It starts using information system from the very long time, and changing the system is very difficult because you don't want to touch something that is working well, right? And you are afraid that, oh, if the data is lost, if this and that. So many banks, of course, need to make use of, for example, phase installation. Okay, we introduce only this module first of the internet banking and start to integrate back to the old system or something like that. Okay. Okay. When you plan to do the installation, to move from old system to a new one, whatever techniques you use here in among these four, okay, there are considerations. That is why I said from the banking as well, data conversion. Old system may use some database technology. New system use different technology. The same data, but moving from one technology to another requires a lot of work. Think about database schema, right? You change the schema. First, it is in this table. Now it is in that different new structure. Before we use relational database. Now we want to use JSON, document, MongoDB, GraphDB, whatever. So changing of the data is a lot of work that we need to be sure. Okay. What if there are errors? Operations don't work on the new system. As I said, that is why some big companies, they even consider parallel because they cannot take the risk of having a failed operation due to changing the new system. Okay. And once the data conversion is complete, okay, without error, everything is done fine. You may need to think of how to shut down the old system and how can you, sometimes it may involve changing business process too. When you change the system, it doesn't mean people work in the same way, right? The operation, the people who give services may need to work differently. And that means your system needs proper documentation plus proper training and support. We're talking about new system. Training and support must be there. Users don't feel familiarized with the new system yet. There will be for sure a lot of problems. Okay. Suppose every one of you, some of you use Mac, some of you use Windows, and maybe you use Linux. I don't know, right? When you change the system from Mac to Windows, Windows to Mac, or to Linux, Ubuntu, whatever, have you got some initial problem of don't know where things are? Have you? Same. That is just your single machine, right? But when we are changing system A to system B, even from manual, doing things manually, or to be doing things on computer, or doing things on legacy system in the past to a very modern one. The same, even you use Windows or Mac. Changing Windows from I don't know. I've been using Windows. The very first Windows I used, Windows 3, very old. Windows 90 something, 95, 98. Then what next? Windows XP, Windows. What's after that? Vista. What else after Vista? Pardon? With 7. Okay. Do we have 8, 9, 10, right? 11 now. We are 11. The user interface also we feel struggling at the beginning, right? That's the same thing for users. Even they are not IT people, right? They might be naive user and so on. So training and support would be very important. And you know, I even don't try hard enough yet, but I have been using iPhone from the very beginning of smartphone era. I cannot use Android. When I use Android of my friends, my children, I need to ask, where can I find this? Where can I find that? Where can I find those? So still, right? But of course, I know it's not that hard, that difficult, but it's just that I found I don't want to learn. That's it. And that could be the same for real users, right? And that is why you are assigned to read user acceptance and user resistance to new technology, to new system. And these are the issues that even your system is very good, well developed, following all requirements that you get from stakeholders, product owner. But when it comes to the real user, you still may get resistance. Why and how to handle them. Okay. Okay. There should be a lot of ways to support, right? By means of training, then this should be regular. Because you do have new coming users. I mean, the company, think about the real company. You don't have everyone starting to use the system from day one until the end, right? You may have new employees coming. How do you train new employees as well? Okay. You may have help desk to support of certain issues. You may have automating support systems such as call center, such as chatbots, such as maybe ChatGPT to answer the system problems and so on. Okay. And once everything is done, okay, these are, as I said, we need to understand that even you deliver everything perfectly, it could be that whether the system will be in use or not. Okay. There are, to make the system in use, there are a lot of factors. For example, the characteristic of the system itself, user personal state, these are factors. User demographics, some of the users may like or may not like new changes, new system. Whether do we have good organizational support on the new system or not? Whether the satisfaction, the performance of the system, management support, and the urgency of replacing and solving the problem and so on. Okay, so these are, for example, factors that affect usage of the new system. But what you will be reading, there are more because these factors evolve, right? The same factors that could be important in the past may not be there anymore, or maybe we have new factors too. And once everything is fine, you transfer the system, deliver, make change, and users are happy. It's the time for you to say goodbye to the project, right? Project closed down. Remember when we talk about definition of project, it has specific purpose. Every project needs to have a goal and purpose. Every project has timeline. You cannot have project forever. Forever project doesn't exist. You can tell me there's no forever project in this world. Every project has start and end. whether extension or not, but still there is an end. So when you close down, be sure to do team evaluation. Okay. It may involve that, of course, people of the existing project, they may be moving to another project. Okay. You need to modify everyone that, okay, the project is coming to an end. Who is going to take care of this system after you leave the project? Maybe not leaving the company, right? But leave from this project to do something else. What would be the person doing the maintenance? Okay, how this is done, and conduct the project review. This is important. You need to know how good, how bad you have been working on the project, right? So that you can improve in the future. Close the contract, formal sign off.